Hope everybody's having a good day. That was a really nice fire drill as far as what I could tell, so thank you very much. Big picture, tomorrow, what's going on? Not a test. Quiz. Okay, it is going to be a quiz, so I'm budgeting 20 minutes for it, so it is a good chunk of the class tomorrow. It's going to be over graphing rational functions. Maybe that's something that we can have the opportunity to kind of review and discuss today if you're interested. Next week, that's when the test is, Thursday the 19th, okay, the short week next week. It is going to cover everything about rationals. I got equations on there, graphing them, finding all the items from the x-intercepts to the asymptotes and everything in between. There's also going to be rational inequalities on there, which we are currently looking at. In fact, what's due on Friday? Okay, the current homework. Okay, so remember, I want you to be aware the homework, remember, is not being taken for a grade, but you do have to have it completed if you want to go ahead and retake the corresponding assessment. Okay, so last week's homework, I still have quite a few people. In fact, I did some stats yesterday. Okay, your class period, when everybody is here, there are 27 people. 21 people have not turned in the homework yet. So 77.8% people in this class have not turned in the homework. So I'm kind of feeling like I might be having to be put in a situation where I'm unfortunately going to have to tell someone you can't retake until you get that done. Hopefully I'm wrong. Maybe we're all going to pass that quiz tomorrow. Everything's perfect. I'm seeing some head shake yes, so I like it. The good news is you're not the highest percentage. Okay. So I'm not going to tell you what class, but there is a class that has a 83% number of people who have not turned in the homework. In fact, all of the classes, 4 of them are in the 70s and only 1 is in the 80s. The people who have not turned in the homework, so just please make sure you're taking care of that. Let's see, what do I got here? You'll notice a code at 6G9DF3. So I went ahead and set up a Remind classroom yesterday. I'll go ahead and send out some Remind texts every now and then, probably the night before we have a major assessment. I am planning on sending one out at the end of school today as a test. If that is something you'd like to join up for, okay, there's the code. I'll definitely have it up tomorrow, probably the next couple of days, make sure everybody has it. So if you want to pull that out right now and go ahead and sign up, you are more than welcome to do that. Okay. And I think that's all I got, unless anybody has any questions. Okay. 6G9DF3. The Joker. I like how everybody went, oh, okay, at once. Yes, Mr. J. Okay. Oh, and I do have it set up where you cannot text me back. Okay. Like, I'm not judging any teacher who has it set up where you can do that. I mean, that is the teacher's personal preference. I just think that's kind of weird. I don't want to get into that situation. So if you want to contact me, email is the way to go, not by text. I'll be able to reach you guys if you sign up, but it won't go the other direction. Okay, so let's see. We talked about the assessments. We have the current homework assignment due on Friday. We could even spend time looking at that today if you'd like. So far, second period is the one who decided to put that homework aside and focus more on graphing the rationals. Okay, so we'll see what you guys decide. But before we get started, how many people had the opportunity to go home, or at least maybe in class yesterday, finish that problem we were working on? That is fantastic. I'm seeing so many more hands. Okay. This is what we should be getting. So hopefully our answers match up. Remember, the sign chart is your work. The final answer is going to be interval notation. Now, this was the first problem yesterday where we came across irrational values coming from the denominator. Okay. And I believe you guys used the quadratic formula, right? Or was it complete in the square? Okay. I know 8th period used complete in the square, so you guys were the only 2 that did that. The other 3 used the quadratic formula. Okay. All right. But there's definitely just one other type of problem that I want to go ahead and show you when it comes to sign charts, and then from there, It's going to be up to you how we're going to go ahead and proceed, whatever you think is going to be the most beneficial. Any questions on this? Yeah, Sandra.
How is between negative 3.14 or 3.41 to negative 5.9 positive?
Okay, well, let's take a look at what we have. Okay, let's go ahead and recreate that. So I just need some value between negative 3.41 and negative 0.59. So what can I choose? Okay, negative 3, okay, would work. Negative 2. I mean, I could even go negative 1, right? Okay, any of those values. You want me to use negative 3?
I just
Oh, so you don't want me to do that? Are you sure? Okay, William?
I used the original expression, the
Yes.
negative 2 plus or minus the third of 2. When I gave my answer, I just plugged that back in for the negative 3.41.
Also, on your sign chart, you actually have the binomials?
Yeah, is that acceptable?
That would be fine. I think it would probably be better. I mean, this is just my personal opinion. If I have a line graph, I think a lot of people wouldn't really know just right offhand. If I had something like, that's why I approximated it. But I don't see a problem with it.
Would be between them.
Yeah, I don't see a problem with that. That's perfectly fine. Okay, good. Any other questions? Okay, well, let's see what else we got. Let me go ahead and put that back up for the next class. Okay, let's look at this last one right here. Now, what makes this one different? There you go. Your first step is to make sure that it's compared to 0. Every problem we've come across so far has already been compared to 0, and it may have even already been factored. Okay, so now we're starting from scratch. We have to take care of some algebra before we can even create the sign chart. Now, personally, I like to pull everything to the left. It's just a habit that I've gotten into. But as long as you have it pulled to one side, where one side is 0, you are good to go. So I'm going to take this fraction, 2 over x minus 1, and I'm going to pull it to the left side. So I have 3 over x plus 2. Now, that 2 over x minus 1, he's positive, so I always use the opposite to get a term to the other side. So when I pull him over, I'm going to have him subtracted. X minus 1 is now less than or equal to 0. Now, with that first step, I can already tell when I'm ready to create my sign chart, what intervals am I going to be very interested in, positive or negative? I'm going to want the negative, okay. What's less than 0? Negative values. Okay, well, if I'm going to pull these together, which is what my second step here is, once you get everything to the same side, combine them into a single ratio, we need a common denominator. Okay, now it's pretty easy to do. You can always simply multiply the denominators and you're going to have a common denominator. It's not always going to be the least common denominator. You may just have a little more simplifying if you multiply all the existing denominators, but this one, if you multiply the denominators, it will actually be the least one. Okay, so I'm looking to have both denominators, x plus 2, x minus 1. If you'll put that in the tray, please. Okay. All right. So I'm going to take 3 over x plus 2. Well, he has x plus 2, but he's missing the x minus 1. Okay. I'm doing the exact same thing I would do if I were dealing with numerical values. I'm just creating an equivalent fraction. Okay. What is x minus 1 divided by x minus 1? Yeah, it's 1. And when you multiply anything by 1, it stays the same, right? So the point I'm trying to make, I'm just changing the way this fraction looks. I'm not changing his value. Oh, thank you, sir. If I were to plug in a value of x. Okay. Now let's do the same thing for the other one. Minus 2 over x minus 1. What am I missing here? I'm missing the x plus 2. Okay, so I'm going to say x plus 2, and this is all still less than or equal to 0. Okay. Now, here's what I would recommend. Once you get everything together into a single fraction, you got to factor everything. Well, I would recommend that when you do multiply these together, don't bother multiplying the denominators. You're going to have to break them back apart anyway. But you do have to multiply and combine your like terms for the numerators. Okay, you have to combine your like terms. So what would I get if I tripled x minus 1? Okay, so this is 3x minus 3 over my common denominator, x plus 2, x minus 1, minus, now I need to double x plus 2, 2x plus 4 over the common denominator. And remember, order doesn't matter when you're multiplying. That's the commutative property. Okay. See, now that they both have the same denominator, I can pull these together into a single fraction. The only thing people miss at this particular part, when you're subtracting a fraction, remember you have to distribute the negative across every numerator. Okay. So help me out here. What would 3x minus 2x be? That's just 1x. Negative 3 minus 4. Negative 7. So see, I've combined my like terms. Over x plus 2, x minus 1, less than or equal to 0. See, now this problem looks like every other problem we've had in our notes. Okay, it is ready to go with my sign chart. Now, I want to go ahead and point out, sometimes after you combine your like terms, it may be possible to factor that numerator. But only after you combine your like terms would you then try to factor. That's always going to be the last after you combine. Okay. So what do you guys think? Do we need to go ahead and finish up this sign chart? Because really the algebra portion was all I was really interested in, but would we like to continue? Yes? Okay. All right. So I've got this rational inequality. All right. So I'm going to create my line graph here. Okay. How do I find the values that are going to go on the sign chart? There you go. Set the two parts, the numerator and the denominator, equal to 0. Fernando. The factored one. What do you mean, man? Oh, you're talking about in the top right? Actually, that's up to you, because this this statement right here is equivalent to the original problem. Okay, this guy right here. So actually, either or would be perfectly fine. Normally, what I do, if I have to do any algebra, I go ahead and put the most current version in the top right corner. Okay. So I'm going to go ahead and take care of that. So x minus 7 over, what was it, x plus 2, x minus 1, less than or equal to 0. Then I put x below. Okay. So now we want to find the values going on my line graph. So I set the numerator equal to 0. So this tells me x equals 7. I'm going to set my denominator equal to 0 because I have multiple groups. I'm going to set them individually. This tells me x equals negative 2. If x minus 1 equals 0, this tells me x equals 1. So these are my values going on my sign chart. Any value of x that makes the numerator or the denominator 0. We just want to make sure they're in numerical order. So I'm going to say negative 2, 1, and 7. Okay. Is that okay with what I've done? Okay. Well, which value or values came out of the numerator? Okay, only 7, he's my what? He's my 0. So we want to make sure, put that 0 above it. We want to indicate that. So negative 2 and 1 came out of my denominator. They are now they would be vertical asymptotes. Here we refer to them, starts with a U. Undefined. We use a no solution symbol to represent that. Okay. And in fact, this is going to help you with the quiz tomorrow. He immediately said those are both vertical asymptotes. Why wouldn't either of those be a whole? There is no cancellation. Only if a term or a group cancels will there be a whole. Okay. What do you guys think about open or closed on negative 2, 1, and 7? Okay, so Natalia says the first two are open and the last one's closed. Wait a minute, it says equal to. Shouldn't I be able to close all three? Yeah, remember, we never include those undefined values. Okay, we cannot divide by 0. So no matter what, you always put open circles on the undefineds. Okay, but the 0, that can be included. All right, well, all we got to do now is figure out which of these 4 regions are now positive and negative. How do I do that?
The first region
Okay, so Andrew says for the first region, plug in what? Okay, so he chose -3. So choose a number on each interval. So I'm going to plug it in for every x that I have. Okay, so let's see. I'm going to recreate this. What is -3 minus 7? Okay, negative number. -3 plus 2? Negative. -3 minus 1. So what would this become? Okay, ultimately a negative divided by a positive, so this should be a negative. So what is this sign chart is telling me is happening if I were to look at his graph? What should I see graphically to the left of -2? That's exactly right. Positive or negative tells me whether he's above or below the x-axis when he's graphed. So whatever he looks like, this negative tells me he's below the x-axis. Okay, what's between -2 and 1 that I could use? 0, perfect. Okay, go ahead and plug it in. 0 minus 7, 0 plus 2, and 0 minus 1. So this is a positive. So graphically between -2 and 1, I should see the graph above the x-axis. Okay. Is anybody having difficulty? Anybody having trouble? Anybody not sure where I'm getting some? Okay. We have several choices here. Something between 1 and 7. Okay, 5, 2 would work. Okay. 5 is the first one I heard. All right. So let's see. 5 minus 7, negative. 5 plus 2, positive number. 5 minus 1, positive. So this is negative. Okay. And last one. Something bigger than 7. 8. Perfect. As long as it's on that particular interval, does not matter what you choose. So let's see here. 8 minus 7. Positive. 8 plus 2. Positive. 8 minus 1. So this region is definitely a positive. Okay. Now that's my work. Okay, that's the sign chart. Yes, ma'am. Are you sure? Okay. But what's my answer? The 2 negatives or the 2 positives? How do I know? There you go. That's why we always want to compare it to 0. That tells me what I want to shade. We're less than 0. I want the negative regions. Okay. So now I want to write that as an interval notation. What would the first one be? Negative infinity to what? To -2, parentheses, because it's open, union, okay, 1, parentheses, 7, bracket, because the 7 was the only included value. Okay. So we don't know what the graph looks like, but I have a really good idea. I know on these intervals where he would be above or below. I know that -2 and 1 would have to be vertical asymptotes. What's happening at 7? That's where the graph would be doing what? Crossing the x-axis. That would be his x-intercept. That's it. Okay. Questions? Okay. Well, there's another problem like this on your homework. It's number 9. Would we like to do another one of those? Do we want to move on to graphing rational functions? What would you guys like? The sign charts will not be on the quiz tomorrow. In fact, I'm thinking probably for Tuesday, I'm going to put together some kind of exit ticket for you guys to work on in class to get some more practice prior to the test. But this will not be on the quiz tomorrow. It will be on the test next week. Tomorrow is just graphing rationals. In fact, if you remember that assignment I handed out last week, the one I was referring to earlier, this guy right here, this is what the quiz tomorrow will be. These types of problems. What's up? You want to graph rational functions? Is everybody okay with that? Yeah. Okay. Do you want me to find one? Is the homework okay? I don't remember what problems we looked at together. Or do you see one of these you would like to go to work together? We did 10 and 14? Okay. And we did 9? Okay. All right.
We just simplified 14.
We simplified 14, but we didn't do it. Do we want to do that one? Okay. What did we get for the factored version? Over x minus 2? What? Oh, okay. Well, give me the whole thing because I think there was a hole here, right? Yeah. So what was the group that canceled? 2x minus 3. And what was it? The denominator? X minus 2. 2x minus 3. Okay. Let's see. 6x squared minus 9x plus 4x. Okay, perfect. 2x squared minus 3x minus plus. Okay, we're good. Okay. All right. So I'm going to have you do this tomorrow. So we have the factored version. That is something you're going to have to do. Okay, you're going to have to factor the numerator and denominator. What's up? It may be out. That was something I gave early last week. That's that practice. It's right there. Yep. Okay. All right, so you will have to factor. Again, if you like that my father method or if you have your own method of factoring a trinomial, okay, good to go. So where would you like to start? What would I find first? Okay, let's start with the whole. How do we know this guy has a whole? Okay, we have a group factor that cancels. Now, I'm still going to set him equal to 0. Okay, so for the whole, 2x minus 3 is equal to 0. What would x equal? Okay, add the 3, divide by 2, 3 halves. Okay, so I know the whole occurs when x is 3 halves, 1.5. But how do I find the y value that corresponds to it? There you go. Every value of x that did not cancel, plug in that 3 halves. So 3x becomes 3 times 3 halves plus 2 over x minus 2, 3 halves minus 2. Okay. So let's see here. That's going to be 9 halves plus 2 over, I can even just go ahead and simplify it further. Okay, 1 half, negative 1 half. Or no, you're right, 1 half. I'm sorry. Yeah, can't think today. So this would be what, 13 halves? 13 halves over 1 half. And what happens when you divide by a fraction? You multiply by the reciprocal. Okay. Actually, that is a negative 1 half, yeah. I thought it was a negative 1 half. So it should be negative 13. Yeah. There we go. So the whole occurs at 3 halves, negative 13. So this is going to be slightly off my grid, and that's okay. So 1.5 is right here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So maybe right there. Let's say my hole's right about there. Okay. Let me go ahead and erase this. Well, I think tomorrow that's not going to be a case. I think this one's just the exception. Okay. Yeah. But, I mean, even if it is off the grid, it's only going to be slightly. It's not going to be something where you would find like 50, something off that far. Caleb? You good? Okay. All right, so we got the whole. Vertical asymptotes, okay. Now, remember, that kind of information is coming from your denominator. We already set 2x minus 3 equal to 0. I'm going to go ahead and set x minus 2 equal to 0, so we know x equals 2. Why is he a vertical asymptote and not a whole?
It is a cancel.
Okay, x minus 2 did not cancel, but he still makes the denominator 0, so he's a vertical asymptote. It's a horrible straight line. I could do better. Maybe. Here, let's do this. I'll make it perfect. No, there was a, yeah, but that's not the one I was looking for. Actually, hang on one second. No, what? It was this one. There it was. There it was. Yeah. Okay. There we go. That's going to look nicer. Okay. That's what I wanted. All right, so that hole is right there. This is x equals positive 2. Okay. All right, what's next? Okay, let's go with the horizontal. Now, how do we know this one will have a horizontal and not a slant? Okay. The powers are the same. We're talking about the degrees. Okay, look for the term that has the largest exponent. Okay, if the largest powers are the same, remember we divide the leading coefficients. So here my horizontal asymptote is y equals 3. Okay. Now, I'm not going to draw it all the way through. Is it okay if you draw your horizontal asymptote all the way through? Yes, perfectly fine. Okay. But I'm going to make sure to label it. This is y equals 3. Okay. Now, under what circumstances might I have a slant asymptote? What's that, Jordan? Not if the denominator is bigger. If the numerator's degree is bigger, like in number 13. This would be an example of one that has a slant asymptote. Okay. So Jordan brought it up. What happens if the denominator's degree is larger than the numerator's degree? It's just 0, the x-axis. Okay. All right. So I got my asymptotes. I got the whole. Where to next? Okay, the intercepts. Now, where would I find the x-intercepts? Okay, bless you. The numerator. Okay, any value of x that makes the numerator 0 is going to be an x-intercept. Of course, there's an exception here because the 2x minus 3 cancel. So for my x-intercept, if 3x plus 2 is equal to 0, x equals what? Okay, negative 2/3. Now you'll notice when I'm writing the equations, when I'm going to go ahead and write the intercepts, make sure to give me the equation, give me the actual coordinate. Okay, so we don't want to go ahead and say, negative 2/3. I actually want you to write negative 2/3, 0. Okay, for the asymptotes, don't tell me, 2 and 3. Tell me x equals 2, y equals 3. Always give me the equation and the actual coordinate. Okay. What's that mean? Oh, is that you had a question? No? Okay. So let's see here. Negative 2/3, let's say, maybe right about here. Okay. All right, where to now? Okay, we need the y-intercept. What was the shortcut for that? Divide the constants. Okay. So basically the idea is that if every x disappears because it's 0, well, the only thing you have left are your constants. So my y-intercept is at 0, negative 1. Negative 6 divided by 6. So 0, negative 1 would be this guy right here. Okay. And is there any other bit of information I would need to go ahead and sketch this guy? Okay. I think we'd be okay. I think we can be pretty confident in where we're going to place our branches. In fact, let me go ahead and erase this. Is this one of those problems where it would be necessary to investigate the vertical asymptote? Should I go ahead and say the limit as x approaches 2 from the left and the limit as x approaches 2 from the right? Is it absolutely necessary? Probably not in this case. Okay. If you want to, you are more than welcome to go ahead and do that to kind of confirm. Okay. Like, for example, on the left side of 2, where do you think I'm going to put my branch? Above or below the horizontal asymptote? What tells me below? Yeah. Those intercepts are below the horizontal asymptote. So I'm willing to bet it's going to look something like this. Okay. Where would my branch have to be on the right side? Above or below? Above. Well, why couldn't it possibly be below? There you go. If it were below, I would have had a second x-intercept, but there's not one there. Okay, so look at the little clues to help you out. It's got to look something like this. Would anybody like me to go ahead and run through those limit statements just to confirm that we are correct.
Tomorrow on the quiz, will there be some of them where we do need to probably do that?
I mean, it depends on the problem. I'll be completely honest. Like on this one, I felt reasonably sure based on the clues we didn't need to, but that's not always the case. I made that quiz over a week ago, and honestly, I don't remember what I put on there. Okay. Now, I will tell you one thing I did put on there. At the very end of all this information that you're finding, I am going to ask you to fill in the blanks on these. What is this called? End behavior. Okay, we're looking at the end behavior when we approach positive or negative infinity. This means we're looking at the far left and the far right side of your graph. As x becomes infinitely larger and smaller, what's the graph doing? What's it approaching? There you go. When you're talking about the end behavior, you really want to focus on the horizontal asymptote. Okay? So as I approach positive infinity, should equal 3. As x approaches negative infinity, it should equal 3. It does not make any difference that I approach 3 from below on the left or above on the right. Okay. Now, let's say this were turned in tomorrow for the quiz. Okay. Pretty decent sketch. We got all of our information. It would not get 100%. I didn't label. There we go. So these points are pretty close together. Maybe you want to go ahead and draw just a little arrow. This right here is negative 2/3 0. This one right here was 0, -1. Remember, label your asymptotes, label your intercepts, okay? Label the whole. This whole right here was, what was it, 3/2, -13? There you go. And there you go. That's what to expect tomorrow on that quiz. Did I lose anybody at any point? Will?
Oh, would you do number 12?
You want me to do 12? Sure. Is everybody okay with this one? Okay. 12. Let's see what that one looks like. How much time we got? Oh, we still got a lot of time. All right, so x plus 1 over x squared minus 3x minus 10. Okay, so let's start by factoring this guy. The x plus 1 is prime. Can I do anything with the denominator? What would it be? Okay, so x minus 5, x plus 2. Would everybody agree? Okay. So let's see here. Laura, is there a hole in this problem? No, why not? Nothing cancels. Okay, good. So that's one less thing to worry about. Okay, so I've done a couple of problems, and at this point you're probably, tired of listening to Mr. West. Who would like to come on up here and take over? Kind of show me what you'd have to do. So many hands going up. I mean, the people at home listening to this, if only you could see. Okay, all right, you want to do it? Okay. Now, let me ask you, are you wanting to do the whole thing?
Can I just go with the flow?
Go with the flow?
Yeah.
Okay. Because I'm sure there's a lot of other people out there who are very willing to come up. Jake, you look like you got a smile on your face. Yeah. It's a math smile. Okay.
What does that look like?
Oh, I got his that. Okay.
So first,
Oh, I forgot to ask you, did you want the recorder?
I'm good.
You don't? You want me to say hello?
Hi guys.
Okay. All right, so she's going straight to the vertical asymptote. Laura already told me there are no holes. Okay, so it looks like we have 5 and -2 for my vertical asymptotes. Okay. She did that way better than I did. And then -2. There we go. Okay. Perfect. Okay.
out the holes, the vertical asymptote. Oh, you can find your zeros. Which is
Okay. So how many x-intercepts will I have?
only one.
Only one. Okay.
Yeah. So. Okay. That equals. Oh, then you have to plug that in. So that means wait, what?
Yeah, now remember, you only plug them in if it's a
Oh yeah.
hole.
This
There
is
you
the
go.
intercept. Sorry.
Okay. So this is the intercept.
Okay.
So remember, the x-intercept always comes from the numerator. Okay, so we have the -1. Good.
Oh, and then our horizontal asymptote, which is 0. What? Oh, okay. Right?
Is she right? Would the horizontal asymptote be 0?
Is it one of the ones where you have to like go like?
Okay, that is correct. What about the degrees tells me that? The denominator's degree is larger, so the x-axis is the asymptote. But see, again, this is why I'm always encouraging you not to draw the middle. We did have an x-intercept. Okay.
Okay. So.
Okay. What's our y-intercept?
Constants.
Constants.
Would it just be -1/10?
Yes. Okay. Oh, we got lucky. It was almost 2/10 in here.
Okay, that's.
Two tenths. 2/10. Really?
Is there anything you can?
This is comedy gold, guys. Come on.
What do we do?
That's a good question. What do we do? Are we talking about because of the joke or the math? Both. Okay. Can't do anything about the joke. Yeah.
Sorry, let me label this real quick.
Okay.
Okay. Well, you see, this is where I leave because I don't know what to do.
Okay. Hey, great job. I mean, she pretty much did almost everything we needed. We just need to go ahead and figure out where my 3 branches are going to go. Now, this is one of those examples I was talking about just a few moments ago. Can I feel 100% confident on the left side saying it would go above or below?
No.
See, there's no information there to kind of lead me to believe one over the other. So this is the type of problem, I'm going to go ahead and erase this, where I would definitely go ahead and use a limit statement. Okay, so let's go ahead and take a look at -2. Now remember, this is just what I've done for a very long time. This is the way I was taught it. I choose a value to the immediate left and right of my vertical asymptote. I use 1/10 of a point. So -2 to the right would be -1.9, 1/10 below -2.1. Okay, what would be to the right of 5? 5.1. To the left would be 4.9. Okay. Now, the only reason I like to choose a value to the immediate right and left, okay, you can move a little further away from the asymptotes, but it is possible that you could get a false positive. Okay, so that's why I just like to use the immediate right and left. Okay. All right, so let's plug in this -2.1, and I erased my factored version. What was that? It was x plus 1 over x minus 5, x plus 2. Okay. So we're going to approach -2 from the left. Remember, if you put a negative or a positive as a power, that tells you the direction you're approaching it from. Okay. So let's see here. If I plugged in -2.1 plus 1, is that a positive or a negative? That's a negative. What's a -2.1 minus 5? Negative. What's a -2.1 plus 2? Negative. So what does this simplify to? That is a negative. Okay. Now that I know this, where should I put my branch? Below. It wants to curve to -infinity, so I know it has to go below. See, we didn't have to do this on number 14 because I had enough evidence to show me where the branches should go. Okay. So you only really want to look at the limit statements if you feel you have to. I mean, you can do it every time if you want, okay, if you're looking for that practice. Okay, now let's do it in the middle. And we can just continue with what we have. We did the negative 2.1, so let's plug in negative 1.9. So now this is the limit as x approaches negative 2 from the right. Okay, because now we're on the right side of our vertical asymptote, negative 2. Okay, so let me raise this up a little bit. So again, I'm just taking the value I chose and I'm plugging it in for every x. Just like a sign chart, I'm only interested in positive or negative. What is a negative 1.9 plus 1? That's a negative. Negative 1.9 minus 5. That's a negative. Negative 1.9 plus 2. Positive, so what's this guy? Okay, he would end up being positive. Now, all I know is that as I go from the right side, as I approach negative 2, this guy wants to curve up. So I'm going to put a little arrow right there to kind of mark that location for me. Okay. Now, just kind of think about what would it have to do as I approach 5 from the left? You think it's going to approach positive or negative infinity? Okay. It would have to approach negative infinity. Why couldn't it approach positive? That's exactly right. Because I got to include these intercepts that we found, right? If he was going to go to positive infinity, I'd come down here, hit the 2 intercepts, but then at some point I'd have to curve back up and hit the x-axis again. But we don't have a second intercept. So that leads me to believe it's got to go down. So it's probably going to look something like this. Okay. And let's go ahead and check that. Let's see if plugging in a 4.9 would give me a negative result. Okay. Oh, is it time? Are we that close? Oh, yeah. Yeah, okay, go. So the limit, as x approaches, what are we doing? 5 from the left. Okay. So on the left side, we chose 4.9. 4.9 plus 1. Positive. 4.9 minus 5. Negative. 4.9 plus 2. Positive, and indeed it did go to negative infinity. Okay. There we go. Okay. Has anybody already figured out what it should be doing on the right side? Is it up? Okay. So it should be up like this. Does anybody want me to show approaching 5 from the right to see that we should get a positive infinity? Does everybody feel a little more comfortable now with when we would need to use that? Sandra, do you have a question? Are you sure? You were just shaking your head no.
No, I don't know enough to not have questions.
Okay. Where did I lose you?
I,
Are you sure? Okay. Anybody else have a question?
so you just use that when you're like stuck with.
Basically, these are what we call your analysis. Okay. I don't feel they're always necessary. If you know where the branches have to go and you feel confident, draw them. Okay. They're just kind of your way of confirming you're correct.
So for tomorrow's quiz, how many questions is there?
I put 2 on there.
Oh, that's scary.
2.
Like the points are broken up between them.
Well, I mean, remember, one of those questions is going to have you find the x-intercept, the y-intercept, horizontal asymptote, vertical, whole. So I'm breaking it up. Even though it's only 2 questions, I'm looking at every blank. So that makes it better. Yeah. I don't want to do one of those 1 and you're done. Then some people just be like, well, I'm done. All right. Good.